All right. Check, check. Okay, that sounds better. Let's take a look at question number 1. We're in section 14.3. So the cumulative percent is to add each previous percent, right? So right now we have 17%. Here we'll have 17 plus 23%, giving us 40. Next we'll have 40 plus 33%, giving us 77. Then 77 plus 18, giving us 95. Let's see, I think I added wrong, maybe, 73. Okay. $73. And then 73 plus 18 then. That gives me 70, 80, 91. That's better. Now 91 plus 8 is 99. And then 99 plus 1 is 100. Where we're just adding each of these cumulatively as we go through the list. Okay, now to find the mean, we take the x times p, right, and make a column, because what we're going to do is sum each x times p and then divide by the p, right, where this is the weighted mean. And the sum of p is 1. So the sum of our p column, that sums to 1. As we saw here, the sum was 100%, right? And 100% is the same value as 1. So now we'll take 0 times 0.7, right? So we do times like that. 1 times 0.23, 2 times 0.33, 3 times 0.18, 4 times 0.08, and 5 times 0.01. When we run this through a calculator, let's see, we're going to have 0, 0.23, 0.66, 0.54, 0.32, and 0.05, right? When we sum this column, we'll be summing each of the x times p. And so 10, 20, carry the 2. I'm going to put it a little higher. So carry the 2. And then we've got, let's see, 10, 15, 16, 17, 18. And then carry the 1, gives us 1.80. Divide by 1 equals 1.80. That's your mean. Your median is the halfway mark, right? The weighted mean is your average. The median is where you hit the 51st entry, right? And so it is after we've collected 40 in this row here where the 51st entry will be. So it's an x equals 2. That's the median. And the mode is your most frequent, right? 33% or twos. And so your mode is also a 2. Number 2 is similar, right? So I'm just going to skip that one. Number 3, you have to do a little extra work, right? In the last problem, we said that the sum of P is 1 or 100%. And so what we have here is, right, first of 5%. 5 plus 15 is 20%. So we have 20% here and 20% here, right? That's going to leave 60 for C, because again, we have to sum to 100%. Now we have 60 plus 20 for 80. 80 plus 15, 95. And then 95 plus 5 or 100. So we first had to find the missing percent for the C's, and we then had to find the cumulative as we did before. Okay. On number 5, what percent of the total population is found between the mean and the z-score given using the table? The table says any z-score larger than 3 use 0.4999, right? So looking at our table, down here, right, for any value above a 3.09, use 0.4999. So that's what we'll use. And 0.4999 is 49.99%. Okay, so now looking at our z-score of negative 0.9, right? We go to our z-score, ignoring the negative, go to your 0.9. And since the hundredths digit was the 0, then we find on the table 0.3159. We said 0.3195, I think, right? So we'll look again, 9 and 0. So we have a 0.90. 0.9 is that column, and then the ending with the 0 is this row. I said it wrong, that row in this column. And again, the intersection is 0.3159. So our answer is, oh, dang it, 31.95%. So 31.95. Suppose that people's heights in centimeters are normally distributed with a mean of 170 and a standard deviation of 5. We find the heights of 70 people. You may need to use the normal distribution table. Use your answers. Round your answers to the nearest whole number. How many people would you expect to be between 160 and 180 centimeters? Okay, so looking at the formula for the z-score, okay, so from section 14.3, the z-score is z equals x minus mu divided by sigma, where this is our point estimate minus the mean divided by the standard deviation. Okay, so here we have a mean of 170 and a standard deviation of 5. And we're trying to find the values of how many people we would expect to be between 160 and 180. Okay, so one thing that we know is our center, well, the center here maybe, right, is 170. When we go one standard deviation above, we're at 175. 2 standard deviations above, we're at 180. When we go 1 standard deviation below, we're at 165. And 2 standard deviations below, we're at 160. And so they're asking us, one, to find the area between these two, right? This is mean plus 2 standard deviations, and this is mean minus 2 standard deviations. If we go back to the book, we can see on this chart, right, that between 2 standard deviations below and 2 standard deviations above, we have almost 95% of the data, right? We have 2.3 on each side that's not being accounted for. So like 2.3% here and 2.3% here. If we add that together, that's 4.6%, right? 4.6%. So 95.4% is 13.6 plus 34 plus 34.1 plus 13.6, right? So that's how we get those about that 95.4. Let's go back to the problem. So we found the area between those two. We found the percentage to be, right, 95.4. So in decimal form, that's a 0.954. And what we're saying is we expect 95% of these 70 people to be between those heights, right? So if we take 0.954 and multiply by 70, then we have 66.78. So I would expect about 67 people. And then in this next one, they're asking us for our expectations that were above 168, right? Again, our center is at 170, and they're asking for everything above, right? This time we're going to need a z-score because this doesn't fit nicely into that graph that we have, right? So we're going to use the z-score for this one. And here we have an x value of 168. We have a mean of 170, and we have a standard deviation of 5. So when we find the z-score for number 9, we're doing x minus the mean divided by the standard deviation. When we plug those values in, we get 168 minus 170 over 5. That's -2 over 5, right? Let's see. That's a 0.4, so -0.4. So we have a z-score of -0.4, and that's a 0.40, right? Now, the way the book gives you info is from between the mean and our z-score, because the other percentage is just 50%, right? So we'll add whatever we get from the chart for a 0.4 z-score. So let's go look over there. If we go to the 0.4, we're kind of on top of it, but it says 1554 there. So here's our 0.4 and the 0. So we have 1554. Now we're going to add that, right? The value we got for this, which was 0.1554. And we're going to add that to the 50%, which is 0.5, right? So this time we're getting a value for a percentage of 65.54, right? But that's the percentage of people that we're expecting to be taller than 168 centimeters. And so we're saying that about 65% of 70, so times 70, that's the number of people we're expecting. So 65%, 65.54 times 70 gives me a result of 45 people with 0.878 also needed. So I would say 46 people. So here we first had to find the z-scores, right? On the first one, guess it's late and I can't spell. Let's see. So first we had to find the z-scores, right? And in A, we could just use a table, like the empirical rule table. For B, we had to use the standard normal distribution table that they gave us the link for. And that was to find the percent. And then we multiplied the percent times 70 because that was the number of people, right? So percent times people. And then let's see, there's kind of a step in here where you draw a picture, right? And that helps us see the between and the more than, right? So a lot of steps for those. Same sort of deal for 10, right? 170, standard deviation of 5, 70 people. This time they want to know between 70, 170, and 180, right? 180 being 2 standard deviations. We can see from that table in this book here, this empirical roll table, we can see that from the center to 2 standard deviations out, we have 34.1 plus 13.6%. So here, let me erase some of this. Got a bunch of circles everywhere. This gives me 47.7, but that's the percent, right? That's the percent. And so we want 47.7% of 70 people, right? And again, for the 176, we would have a value about right here that they're then asking us to find the rest of, right? And so in order to find that value, because the book gives you what's between the middle and your z-score, you're going to have to take the area the book gives you and subtract it from 50%, right? Because this whole side would be 50%. So we want to take 50% and subtract A, right? Z-scores are X minus mu over sigma. So we have 176, that's our X value, minus our mean, 170, divide by our standard deviation, 5. 6 divided by 5 is 1 1/5. That's 1.20. So we'll go to the standard normal table, look up the 1.2 z-score. It ends in the 0. So we have a 0.3. This value here is going to be 0.3849. And we're going to subtract that from 50 because the area they gave us, again, is between the 170 and the 176. But we want to know how much is beyond that, right? So we're going to take our 50% and subtract from it the 3849, right? Let's see. try to keep track of it. So 1, 5, 1, 1. So 0.1151, that's a percentage. So we have 11.5% of 70 people, right? So when we multiply those out, A being 0.477 times 70 looks like 33 people about. And for B, 0.1151 times 70 is only 8 people. Oh, look, there's that chart we were looking at. So that's good. Suppose that for a certain exam, the teacher grades on a curve, right? That's true. It is also known that the mean is 60 and the standard deviation is 5. There are 55 students in the class. So this is the same sort of thing, right? The group of C's are this group, right? Then you have your B's and your A's. And then going down, you have your D's and your F's. So you're expecting most students to be in this bubble, right? So how many students do you expect to get a C? That's 68.2%, right? Adding the 34.1 twice. So, and that's of 55 students. So to write that, we have 0.682 times 55. That will be 0.682 times 55, 37.51. So of the 55 students, we would expect about 38 to get a C, right? So most people get a C. The A group is 2.2% plus 0.01%. So like 2.3% of people will get an A. 2.3% of 55 is like one person probably. So 0.023 times 55, right? 0.023 times 55, one person. 1.265, which rounds to one individual. And as an instructor, I generally find this to be true, right? You're going to have the bulk of your students get a C, because what a C means is what most people understand, right? So it's common knowledge. Here, same curve, but they're asking us what would be the necessary score to get an A. So they tell us the mean is 60 and the standard deviation is 5, right? So in this course, the A's are 70 and above. Here we have, if an exam paper is selected at random, what's the probability it will be a failing paper? Do they consider a D a fail? Or are they looking at just F's? That would be an important question to know the answer to, right? So if they're considering D's and F's, right, then we're looking at 13.6 plus 2.2 plus 0.1%, right, which is 15.9%. And we're quantifying this by saying below a C, right? And that is 15.9% of 55 students, which is 0.159 times 55. So we have 0.159 times 55. That gives me 8.745 students, which I would round to 9, right? Otherwise, if they asked how many individuals were just Fs, right? If that was the same, then the number of A's will be the same as the number of F's, right? And so if we're looking at it in terms of that, right, we said something like there was one A, so there would be one F, right? And then adding the D's and F's got us 9, I think. So there must be 8 D's and 8 B's, right? So 18. That leaves us with 37 individuals in the middle. And due to rounding or whatever, right, that seems to check what we had before, because we had 0.682 times 55, which was 37.51, and we rounded to 38. So we didn't adjust that one very much. And we actually had to adjust probably the B and D to compensate for that partial. So it's coming out in the wash, but that's the 55 students then, right? 31A, 8 B's, 37 here, just for illustration, C's, right? 8 D's and 1 F. So when you guys are asking us to grade on a curve, when you're like, please grade on a curve, right? This is what you're asking for. This is the curve, right? It's the curve that everyone asks for. So let's look at the 14, I think. Z-scores, right? So here they have Z-scores for us. They should have given us these formulas before. A normal distribution has a mean of 85.6, a standard deviation of 4.89. Find the data value corresponding to the value of Z given. So they're asking us to unstandardize, right? So if Z equals X minus mu over standard deviation, then solving for X, we have mu plus Z times sigma. So here we just have 85.6. I'm going to write it below, I think. $85.6 plus 0.55 times 4.89. So this one is Z-score is called standardizing. And what we're doing is unstandardizing. Point 0.55 times 4.89 equal sign plus 85.6 equal sign 88.2895. And they wanted to 4 decimal places. So we would give that full answer. And then you just do the same thing for these, right? It's still the same value. So X equals mu plus Z times sigma. The only thing that changed is Z. So this time we're gonna multiply 2.55 onto our 4.89 and then add that to mu. This time I get 93.04. So 93.04. And here, the only thing that's changed then is we have a negative 3.41. But the z-score is the only thing that's changed here, right? So 85.6 minus 3.41 parenthesis 4.89 gives me 68.9251, and they want the whole answer. I would maybe even add zeros until it was 4 on that one, just if you're nervous. Okay, so that was that stretch, right? Now we have, suppose that a certain mathematics class, the scores are normally distributed with a mean of 75 and standard deviation of 8. The teacher wishes to give A's to the top 7% of the students and the bottom 7% F's. The next in either direction is a 17, with the other students receiving C's. Find the bottom cutoff for receiving the A grade. Okay, so what they're saying to us, right, is this time we have 1, 2, 3, 1, 2, 3, right? We've got our A group, our B group. Oh, no, wait, I cut it too early. Okay. Let me redo that one. Here's our C group, right? That's our group of C's. That's the middle. And then we've got our B group here. And then our A group here, right? And they're asking us, what is this value that starts us getting the A, right? And so what we need to do is we need to find the z-score for this location, right? When we reread the problem a little, they're telling us that the area of the A's is 7%. If we then remember that the area of 1/2 of this is 50%, right? So we have 50% of the graph on one side of the median, mean, and we have 50% on the other, right? Then the area that's right of center, that before we get to the A, that's going to be 43%, right? Because 43 plus 7 is 50, right? So we need to find the z-score that has an area of 0.43. So if we go to our table, we look at the body and we look for something close to 0.43 in the body. There's a 0.4292, right? So I'm actually going to erase this so we can see. Okay, so we have 0.4292. That's off by 0.008. And then we have 0.4306. So that one's actually closer, right? So what we're going to do is we have a z-score of 1.4, and then we have to go up to the top of this column, right? So right now we have z equals 1.4. And this is actually our 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Because those are our ending digit in the hundredths location. And so we have 1.48 as our z-score, which, let's see, 1.48. We're on number 18. We're getting there, right? We have the x equals mu plus z times sigma. Mu is 75. The z-score we found was 1.48, and the standard deviation is 8. Right, so we have 8 times 1.48 equals plus 75 equals 86.84. Round your answer to the nearest whole number. We expect 87 to be the grade at which you get an A, right? Okay. Suppose that the breaking strength of a rope in pounds is normally distributed with a mean of 100 pounds and standard deviation of 16. What's the probability that a certain rope will break before being subjected to 140 pounds? So we have an X value, a mean value, and a standard deviation. The z-score for this, x minus mu divided by sigma, is 140. Take away 100, divide by 16. So 40 divided by 16 gives me like a 10 divided by 4, right? 5 halves, which is a 2.5. So we have a z-score of 2.5. And so before reaching 140 pounds, so that's going to look like anything before 140 will have shaded, right? The book is going to give us information for between 100 and 140. That's what the book's going to give us. So we're going to add that to 50%, and then we should have our answer, right? So this is before reaching 140 pounds. So we have a z-score of 2.5. That gives us a value here of 4938. 4938. Okay, so we're going to add the 49.38%. We're going to add that to that 50%. So in total, this whole shaded area, 50 plus 49.38, gives me a value for 19 of 99.38%, which they want in the, oh, sorry. 99.38. Right, because they're looking for probability, not percentage. And it's the same sort of deal with these, right? The diameter of an electric cable is normally distributed with a mean of 0.8 and a standard deviation of 0.03. What's the probability that the diameter will exceed? So more than our X value of 0.83. So we look for a z-score, X minus mu, divide by sigma, right? X, we said is 0.83. Then we're going to take away the mean of 0.8, divide by the standard deviation of 0.03. That gives us 0.03, divide by 0.03, which is a z-score of 1, right? And you want to know about exceeding a 1, right? So we want to know what's going on this side. If we were to use our charts from above, right, then above the 1 is 13.6 plus 2.2 plus 0.1. That was our 15.9, right? 15.9%. So we would expect on number 20, we would expect the probability that the diameter will exceed 0.83 inches to be 0.159. 0.159, because they want the probability, not the percentage, right? So decimal form. Number 21, we have, suppose the annual rainfall in Ferndale, California is known to be normally distributed with a mean of 35.5 inches and a standard deviation of 2.5 inches. About 2.5% of the years, the annual rainfall will exceed how many inches? And so they're asking us to find the X value of having 2.5% beyond it, right? So one thing that we have to do is consider how much area is between the middle and this spot, right? We know that from the middle on, it sums to 50%. So this must be 47.5% here, right? In terms of what we look up in the book, that's a 475. So we need to find, first of all, what z-score does that correspond to? And from there, we can then say what X value that corresponds to. So 475 in the body, we've got a clean one, 475 right there. So you go out to your edges, right? And you try to find your z-score 19. And then this is column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have an ending number of 6. So we have a 196, a z-score of 196, right? Here. Now, what's X, right? Because X is the question. X is the mean plus the z-score we found times the standard deviation. The mean is 35.5. The z-score is 1.96. and we're going to multiply that onto the standard deviation of 2.5. 2.5 is the inches of the standard deviation, coincidentally also that percentage. So if that comes up in yours as different numbers, just remember that's the standard deviation. So 1.96 times 2.5 equals plus 35.5 equals, that gives me a 40.4. Round your answer to one decimal, no need, right? 40.4. So sometimes we're standardizing, sometimes we're unstandardizing. In 22, the diameter of a pipe is normally distributed with a mean of 0.5 inches and a variance of 0.0016. What is the probability that the diameter of the randomly selected pipe will exceed 0.58 inches? So they give us a hint. The variance, if you recall, is S squared, right? So S is to take the square root of the variance, and then we get S. So the square root of 0.0016 is 0.04. So we have a mean of 0.5. We have a standard deviation of 0.04. We have an X value of 0.58, and they're asking for exceeding that value, right? So we're looking for the area off to the side here. Now, again, we get the value from the middle to the z-score that we come up with. And so we're going to have to subtract that from 50, right? So 50, take away the value the book gives us, will leave us with the shaded area, right? So first we have to find a z-score. Z equals X minus the mean divided by the standard deviation. X is 0.58, mean is 0.5, and standard deviation is 0.04. From here, we have 0.08 divided by 0.04, which gives us a value of 2. So we have a z-score of 2 to look up, right? We could look at our other charts from above too, actually, because when we have a z-score of 2, right, we're saying that we have 2.2 plus 0.01 for a 2.3%. That's above 2 standard deviations, right? So 2 standard deviations above the mean. I think we were at like 21, 22 there, right? That gives us, are we done? Probability. So probability wants us to do 0.023, 0.023 for 2.3%, right? 0.023. All right, so we're almost done here. We just have a couple more. They're along the same lines, of course, right? This time we have a mean, we have a standard deviation. They're asking us for the probability. They give us an X value and ask for the exceeding, right? So it's the same as we've been looking at. And we first find a z-score, right? So z equals x minus mu over the standard deviation. That will be 32.5. Take away 35.5, divide by 2.5. This time we have negative 2.5 over 2.5, which is a z-score of -1. They still want to know about what the exceeding this is, right? So if we go back up to one of our charts, we can see that the below the mean by 1 standard deviation is this line here. And so to exceed it will be all of this value, 34.1 plus 34.1 plus 13.6 plus 2.2 plus 0.1, right? So that is 68.2 plus 15.9, 68.2, 68.2 plus 15.9 equals, that's 84.1, right? And these are all percents. And so this one here is a percent, but I bet they ask us for a probability. So 0.841, right? That was like number 22, right? What is the probability that the rainfall in a given year will exceed 32.5 inches in Ferndale? That will be a probability of 0.841. And last but not least, right? Oh, we got a variance one again. So if variance is s squared, right, then we root it, we get s. So here s is the square root of 0.16, which is 0.4, right? We have a mean, that's what net weight is here. Oh wait, oh yeah, they're the same number. So mu is 13, standard deviation is 0.4, we decided. And here, what's the percent of packages that will weigh less than the mean, right? We have a middle of 13 ounces, right? They're asking us for everything over here. That should just be 50%. Right? If you wanted to go a harder route, you could go for like finding the z-score, but the z-score is 0, right? Looking up a 0 z-score, that sort of thing. But intuitively, we know that what's less than itself here, the middle, is 50%. Okay, so just note to self though, in case your numbers aren't exactly the same, right? Here we'd have a 13, subtract 13, divide by 0.4, gives me a 0 over 0.4, which is 0, right? So if we look this value up in the table, look up a 0 z-score, you can see that the area between itself and that z-score is nothing, right? And so we just have the idea itself that 50% is the halfway point there. So okay, so the table doesn't even really help us on that one. Over here, though, what weight will be exceeded by 2.3 of the packages? And so 2.3 sure sounds familiar. Let's go look at one of these, right? 2.3 is 2 standard deviations above the mean, right? So if you look there, you've got mean plus 2 standard deviations, giving you 2.3%. Go double check our question. What weight will be exceeded by 2.3% of the packages? Exceeded means greater than. So we need mu plus 2 sigma, which is 13 plus 2 times the 0.4 that we had from square rooting this value here. So that gives us 13 plus 0.08, or a value of 13.8. So 13.8 ounces, only 2.3% of the packages will be heavier than this. So that is probably, I don't know if it's the most difficult homework, but it's definitely a difficult homework. Hopefully that helped. If not, feel free to reach out to me and ask questions. Thank you.